To rocket launch. So for our project, we might build something similar to this with a little rocket ship burning fuel, and we're going to add in some other cool colors and stuff. So in this project, we're going to use images for our animations. We're going to repeat actions using for loops, and we're going to join conditions with an and conditional statement over here. Now, you can go down below over here and you can play with it. So if you run this program over here, it'll ask how many kilograms of fuel would you like to use. So let's say I used 10,000 over here and I ran. We can see the rocket ship running and the fuel going that far. And I was only able to make it this far. It turned red because we ran out of fuel. We couldn't make it past orbit. So we're going to build something just like that. You need to supply the rocket with enough fuel to reach the satellite orbit. Try a small amount, around 10,000, and a very large amount. So if we run this again and we run maybe 50,000, and we can see what happens. So rocket ship is burning the fuel. It's able to get past 10,000, and then it's able to get past 20,000, 25,000, and it left orbit. So it had this much fuel left. We were able to make it this far, and then it stopped because that was the destination it was trying to go. So we're going to build a project using these things, and it talks a little bit about computer simulations in the project. They're used to calculate what will happen, and using it as a simulation reduces the risk or expensiveness of that. That way we are able to, just see what would happen if we were to simulate it. Not perfect, but some more cool information. Dorothy Vaughan made important contributions to spaceflight. Seeing that the future would use electronic computers, she taught herself and her team how to code. The film Hidden Figures tells the story of how her and other black women played a key role in the success of the U.S. space program. Really great movie. You guys should check it out. All right, setting the scene. The launch animation needs a space backdrop with a planet to launch the rocket from over here. So this is where we're going to be starting the project. We're going to open the project template over here. I like to do control click so it opens a new tab. And I'm going to split my screen so my instructions over here on the left with Windows left. And I'm going to drag out this project starter code over here to this side. That way I can get going. I'm going to minimize that, and there we go. So just be aware that for my setup over here, I'm going to delete it so it starts back to the start right now. Alright, perfect. So if you run your program right now, just as is, you'll get an error because nothing is currently in your draw definition. So let's get started. Make sure you're signed in. You'll use a screen size variable to set the size of the screen and in calculations over here. Variables defined outside functions are global, so you can use them anywhere in your program over here. Find the comment, set up global variables, and we're going to go ahead and make a screen size variable. So we'll say screen underscore size, and that is equal to 400 over here. So we've done this step. We're going to check that part off. We set up the global variable of screen size. Now you'll notice we also have P5. So this library has all sorts of code we didn't write, and we'll be using these two libraries, P5 and random, in order to build our program over here. All right, use the screen size variable to create a square 400 by 400. So I'm going to go to my def setup, which is already there for us. So it's our definition for the setup function. And right below there, we're going to type size. Now, I know a lot of people are going to be like, oh, I should type screen size, comma, screen size. But that is not what you want to do, because it literally wants you to put 400 by 400 there. Under the size over here, you could say how big you want the world. So right here, you're going to say 400, comma 400 to make a square that's 400 by 400. And if we run this right now, again, still nothing's going to happen because my draw function has nothing in it, so we have to keep going. But we've set up size 400, 400, and we'll play with that in a moment. The starter project has 3 different planet images and the moon provided for you. You can view these in the Trinket image library by selecting the View and Image Add buttons, which is this icon over here. Images, we can always add one, and we have the moon, orange planet, and purple planet, and we have the rocket image over here. So we're going to have access to be using those. So decide which one you want to use. So in this one, I'm going to use the purple planets. So it's a good idea to load images in setup so that they are ready when you need to use them. So we are going to use it in setup. The image mode center line says you'll be positioning images by giving the coordinates of the center of the image instead of the top left corner. Because if you remember from the archery project, the coordinates started at the top left over here. So add code to the setup function to choose your image, and the variable needs to be global so you can use it later when it's needed to be drawn. Okay. So define setup size is 400, 400. We already built that one up here, and we can check that part off. We've read that. And then after that, we're going to type, as it said over here, image underscore mode, parentheses, center. That way the coordinates start at the center over here. And then we're going to say global planets, which will allow us to use planet everywhere. Make sure these words are spelled right, otherwise it's not going to work properly. I see a lot of people misspelling these. So global planet, and then what is planet equal to? Planet is equal to load image, so it will pull the image. And which image? So if you type planet PNG over here, you're going to get this Earth-like image. I wanted the purple planet, so instead of typing planet, I'm going to have to type purple underscore planet.png. So I'm going to say over here, purple underscore planet.png. And then make sure you have that last parenthesis, or what's it called? So the apostrophe over there, and then we've checked off that step. But if we run it, we are still going to get an error, and that's because nothing's under draw. So define a draw background function to draw the background. Below the comment tells you where it should go. Use background 0 to set the background color to black, and add an image function to draw the planet. So image is going to be the file name, comma, where you should draw it, the coordinates over here, the width and the heights. The P5 library sets the global width and the height based on the screen size, which is what we were saying over here for size. Size is a P5 command over here. So define draw backgrounds. So where are we going to draw the background? The draw background function goes here. So right over there, we're on line number 15. We're going to say def draw underscore backgrounds, open parentheses, close parentheses, colon, backgrounds 0. This is going to set the color to black. Then image is going to be equal to planet comma, make sure you're typing this correctly, width divided by 2, comma, height, comma, 300, comma, 300. So we're setting right now the width and the height to 300, comma, 300 over here. So it says over here, putting all the code for the drawing background function into 1 makes your code easier to understand. So I click run, we're still not getting anything to work. So it's defined over here, but it's not running. To make the background appear, we have to call draw background under the draw function over here. So we're defining what the background should look like, and then down below over here, under our draw function, we are going to call it. So under define draw, make sure we have 1 tab worth of indent. So if we go to the left-hand side over here, so you see how the definition's on the left. If we click down, we're going to click tab once so that we're aligned over here. And then we're going to say draw backgrounds, open parentheses, close parentheses. And now if we run this over here, we have successfully drawn the backgrounds. And if I full screen this over here, we can see that I got my purple planet at the bottom over here. If I wanted a different planet, let's say I wanted the orange planet, all I would have to do, because it's already built, is I could go back to purple planet and change the name to orange planet. And if I run it again, now I have that orange planet. And I could even add my own image if I wanted. So if I wanted to include some sort of thing from Google, I can find that image, and then I could upload that image. I just clicked the wrong thing. Under this over here, how to use images, I could upload a new image to the image library. So if I had an image prepared, which I totally don't, but let's see if I can find something on my desktop. If I wanted to use out of the F&M logo, sure, why not? One of my colleges, I could then say, it says fnm.jfif. So now that that's been uploaded, I could then change it in my logo to that would appear. So I would have to change that to F&M, what did I name it? This is .jfif, fnm.jfif. So if I run this now again, I have that F&M logo. So that's how you upload the image. I'm going to change this back to purple planet. Purple planets.png, and then we got the purple planet back over here. Also for the screen size, if you were to change the screen size from 400 to like 300, if you wanted to mess with that stuff, you'll notice that the world just gets smaller over here. It's not as far down as it was previously. So try messing with the different numbers and see what happens. Instead of 400, 400, what would happen if you did 200, 400 over here for your screen size? You're only going to be getting half of that screen over here. So this is what's determining how left and right. And then just as you may have guessed, this one's going to determine how up or down this is. So that's going to be a world where it's half as high over here. Okay, so those are all the different amounts. We have global planet, so that planet over here can be used anywhere in the program, specifically down here when it gets called, and a lot of other places later. So over here, this is the first step of the project over here. We've drawn the backgrounds, we've run our code, we have our planet running over here. Next up is liftoff for part 2 of the video. I'll see you guys in the next video. Peace.